Imagine you are standing outside, and the ground under your feet stops moving. Not a tremor, not an earthquake. The planet simply stops turning. You get about 1 second to notice the silence before physics arrives to collect. Right now, if you are anywhere near the equator, you are moving at 1,670 kilometers per hour, faster than a rifle bullet. You cannot feel it for the same reason you cannot feel your own pulse until you go looking for it. It has never once changed. The air moves at that speed. The ground moves at that speed. The coffee in your cup moves at that speed. Gravity and friction have held every part of this planet in sync for 4.5 billion years, and your brain filtered the whole arrangement out before you were born. Because if the ground stops, you do not. Newton's first law is indifferent to your circumstances. An object in motion stays in motion until something acts on it. The crust would halt. You, the oceans, the atmosphere, every parked car and every loose rock would keep moving east at 1,670 kilometers per hour. The oceans would not splash. They would surge east as a tsunami measured in kilometers of height rather than meters, scouring continents down to bedrock. The atmosphere would arrive as wind thousands of times stronger than any hurricane on record, hot enough from friction alone to set forests burning. This is not the disaster film where a few people hold on and survive. Near the equator, there would be nobody left to describe it. Consider what that does to anything tall. A skyscraper would not topple. It would be sheared off at its foundation because the upper floors would keep traveling while the base tried to stop with the bedrock underneath it. Bridges would fold. Everything humans have ever built, from the pyramids to the tower you can see from your window, would become a debris field inside the first few minutes, and the debris would still be supersonic, doing its own damage to whatever was left standing. The poles are no refuge. The ground there is barely moving, but the atmosphere above it is not a separate object, and the shockwave would cross the whole planet. Nothing in nature could stop the Earth like that. But the spin is not a fixed constant either. It is a quantity that has been draining away since before there were oceans to slosh, and the thief is the moon. Every tide the moon raises is a bulge of water that the planet's rotation drags slightly ahead of the moon itself, and the moon's gravity pulling back on that bulge works like a brake pad pressed against the crust. The energy has to go somewhere, and it goes into the moon's orbit. Bounce a laser off the reflectors the Apollo astronauts left on the lunar surface, and you can measure the result to the centimeter. The moon is retreating from us by about 3.8 centimeters a year. In exchange, our day gets roughly 1.8 milliseconds longer every century. That is measurable on a human timescale now, because we no longer define time by the planet. Since 1967, the second has been defined by the vibration of a cesium atom, not by the Earth, and the two have been quietly disagreeing ever since. 27 leap seconds have been inserted into world clocks since 1972 just to keep atomic time in step with the turning of the ground. And the disagreement is not a smooth drift. Shifts in the atmosphere, the oceans, and the liquid core nudge the length of the day by fractions of a millisecond from year to year. On the 29th of June, 2022, the Earth completed a rotation about 1.6 milliseconds faster than 24 hours, the shortest day on record at the time. The long slowdown has weather of its own. In 1851, a French physicist named Léon Foucault hung a 28-kilogram brass bob from a 67-meter wire under the dome of the Pantheon in Paris and set it swinging. A pendulum's plane of swing has no reason to change direction. Over the course of an afternoon, this one crept steadily clockwise, about 11 degrees an hour, knocking over markers set around the floor one by one. The pendulum was not turning. Paris was turning underneath it. And the rate gives away your latitude. At the North Pole, the plane would come full circle in 24 hours. Exactly on the equator, it would never turn at all. For the first time, anyone who could walk indoors could watch the planet rotate. For the slowdown, the record is written in coral. Coral skeletons lay down fine daily growth ridges, bundled into annual bands, the way a tree lays down rings, which makes a fossil coral a calendar that counted the days of a year that ended before there were forests. In 1963, a Cornell paleontologist named John Wells did exactly that arithmetic on Devonian corals around 400 million years old, and found close to 400 growth lines per annual band instead of 365. The year had not changed length. Earth's orbit was the same. The days were shorter. A Devonian year had 400 sunrises in it, and every one of them came faster than yours. Push further back and the numbers get stranger. Layered tidal sediments called rhythmites, which preserve the rhythm of tides the way coral preserves days, put the day at around 21 hours, some 600 million years ago. Go back to the very beginning, to the aftermath of the impact that formed the moon, and models put Earth's day at something like 5 or 6 hours, with a moon looming enormous and close overhead, raising tides that would have erased anything we would recognize as a coastline. Everything since has been one long deceleration, and the calendar is the odometer. Run that trend far enough forward, and the day stretches until it matches the month, and the planet locks to the moon, showing it one permanent face, the way the moon already shows one face to us. In practice, the sun will reach the end of its life first, but a world can lock to its star instead, and that version is easy to picture, because it is horrifying. The sun stops crossing the sky. One hemisphere holds it fixed overhead forever. The other never sees it again. The lit side climbs past boiling, and its water leaves as vapor. The dark side falls so far that the air itself condenses and snows out as frozen nitrogen and oxygen, leaving bare ground under vacuum. Between them, a ring of permanent twilight, where the sun sits on the horizon and never moves. This is not a thought experiment without examples. Astronomers call them tidally locked worlds, and they are probably everywhere. Red dwarfs are the most common stars in the galaxy, and their habitable zones sit so close in that a rocky planet there gets locked almost immediately. The 7 planets of the TRAPPIST-1 system, 40 light-years away, and Proxima b, the nearest exoplanet to Earth at just over 4 light-years, are all expected to be in exactly that state. Researchers asking whether such worlds could support life keep arriving at the same narrow answer: the terminator zone. That thin band of eternal dusk is where liquid water could survive, between the furnace and the freezer. A stopped Earth would not be a new kind of planet. It would be a very common kind of planet, with 8 billion people trying to reach the twilight. Rotation is also doing things for you that have nothing to do with daylight. About 3,000 kilometers beneath your feet, an ocean of liquid iron and nickel is convecting, and the planet's spin twists those currents into organized columns. That is the geodynamo, and it generates a magnetic field reaching tens of thousands of kilometers into space, standing between your atmosphere and the solar wind, a steady blast of charged particles that would otherwise strip the air away molecule by molecule. We know how that story ends because we can watch it happening next door. Mars lost its dynamo roughly 4 billion years ago, and NASA's MAVEN orbiter has been measuring the consequence directly. The solar wind is still peeling what little remains of the Martian atmosphere off into space today. Stop the rotation, lose the field, and Earth begins the same slow conversion into a dry, irradiated rock. The spin also writes the weather. The Coriolis effect, the consequence of the ground beneath a moving mass of air, itself moving at different speeds at different latitudes, is what makes storms rotate, counterclockwise in the northern hemisphere, clockwise in the southern. It is also why no hurricane forms within about 5 degrees of the equator. The effect there is too weak to spin one up, which is why Singapore has never had one. In the oceans, it drives the great gyres that haul warm equatorial water toward the poles and cold water back. Take the spin away, and the water no longer bulges at the equator at all. Models of a non-rotating Earth show the oceans migrating poleward until the planet has 2 polar seas and an unbroken belt of dry land wrapped around its middle. and the machinery that moves heat around the globe simply stops. Warm stays warm, cold stays cold. Nothing mixes. There is even infrastructure that exists only because the day is exactly as long as it is. Park a satellite 35,786 kilometers above the equator, and its orbital period comes out to one rotation, so it appears to hang motionless over a single point on the ground. Every television dish bolted to a wall and aimed at an invisible fixed spot in the sky is pointed at a consequence of the Earth's spin. So the spin is not scenery. It is the reason there is air over your head, the reason heat leaves the tropics, the reason a storm turns, the reason a bullet drifts, the reason a satellite can hold still, and it is running down. Not on any human schedule, but measurably. About 1.8 milliseconds of X-day per century, filed away in atomic clocks and in the growth lines of 400-million-year-old coral. The clock on your wall is calibrated to a planet that is very slowly, very quietly letting go.